Alright people, so solving systems of linear equations by elimination. So we've talked about graphing and substitution, and now we're going to do our last one today, which is elimination. Which essentially what we're going to do in this is try to make one of our variables disappear by adding or subtracting our two equations, and then solve for the one remaining variable. So your first step is to actually multiply one or both equations by number that will create opposite coefficients for one variable. Now that's the important piece. We need to have opposite coefficients. Opposite meaning they have different signs. Coefficients obviously meaning the numbers in front of the variables. What we're going to do then is after we have opposite coefficients for one variable, we're going to add the resulting two equations, which should give us one equation. So when we do that, we're going to have one equation with one variable. Now there are some special cases where that's not necessarily the case, but they're going to be again infinite or zero solutions. Once we have that one equation with one variable, we solve it for the remaining variable that we have, and then we need to substitute that back into either the original equation or any of the other equations and solve for the one remaining variable. Remember, we need both x and y here. Okay, so the hardest part, opposite coefficients, means they have different signs but same number. Okay, so here if we want opposite coefficients for our x, this one we can just multiply. One way to do this to make it easy is always multiply both equations by some number. So I could take my coefficient of x in the second one and multiply the first equation by that, my coefficient of x in the first equation, and multiply by the opposite of that in the second one. And then this is just distribution. So we'd have 12x minus 4y equals 2. And distributing on the second one, negative 12x minus 18y equals 30. So I just distribute the negative 6 to all three and the 2 to all three. And now you'll see that our x's have opposite coefficients. One more example of that if we want to do it for y. So it doesn't matter which one. We still are going to take our coefficient from y in the second one, multiply it by the first, our coefficient of y in the first one, and multiply by the opposite of it, and then distribute. So 8x plus 10y equals 70, and distributing the other one, we have 15x minus 10y equals positive 45. And so you see here, now we have opposite coefficients on the y. We'd solve for the x first. So an example of that, we've already multiplied these. We said by 2 and by negative 6. And that gave us our two equations of 12x minus 4y equals 2. And the second equation was negative 12x minus 18y equals a positive 30. And so after that step, we want to add our two equations. So these two should cancel out. They should always cancel out either your x's or y's. We'd have negative 22y equals positive 32. And solving for y, we divide both sides by negative 22. And that tells us that y is negative 1. We're going to round to 1.45. That gives us our y value. What we need now is our x value. Like we said, we can plug it in any equation we want. If I take that and I plug into my second equation. So 2x plus 3 times a negative 1.45 equals a negative 5. And I solve that. So 2x plus, I need to do 3 times negative 1.45. And I'm going to get negative 4.35 equals a negative 5 still. And then if I add that 4.35 to both sides, I'm going to have 2x equals, and negative 5 plus 4.35 is going to give us a negative 0.65. And then divide that by 2, and I get that x, in this case, is a negative 0.325. So those would be our two values. Remember, you need to have both x and y. So we could even write this as a coordinate, like a point of intersection, and we would need negative 3.325 and negative 1.45 for our y value. That would be your solution, just like when we were graphing and we had a point of intersection. Okay, so that is it for elimination. We've now done graphing. We find a point of intersection, substitution, and elimination. I see you next time.